Hello everyone, welcome back to the channel. In this video, we will be discussing the basics of physics. So friends, what is physics? Physics क्या है? Mr. Anderson explains the importance of physics as a science history, and virtual examples are used to give the discipline context. Physics uses the scientific method. Physics uses the scientific method to help uncover the basic principles governing light and matter. So it uncovers the basic principles governing light and the matter, and to discover the implications of those laws. It assumes that there are rules by which the universe functions, and that those laws can be at least partially understood by humans. So physics, what is physics means? It assumes the rules by which the universe functions. So, so the rules by which the universe functions, so that rules are converted to laws, which can be at least partially understood by the humans. It is also commonly believed that those laws could be used to predict everything about the universe futures if complete information was available about the present state of all light and matter. Matter is generally considered to be anything that has mass and volume. What is matter? Matter is nothing but which which is considered to be anything that has mass and volume. Any anything that has mass and volume is called as matter. Many concepts integral to the study of classical physics involves theories and laws that explain matter and its motion. The law of conversion of mass, for example, states that mass cannot be created or destroyed. So mass is neither created nor destroyed. Further experiments and calculations in physics, therefore, take this law into account when formulating hypotheses to try to explain natural phenomena. Physics aims to describe the functions of everything around us, from the movement of tiny charged particles to the motion of people, cars, and spaceships. So, the physics basically aims to describe the function of everything around us, what is happening around us, from tiny charged particles to the motion of people, cars, and spaceships. In fact, almost everything around you can be described quite accurately by the laws of physics. Consider a smartphone. Physics describes how electricity interacts with the various circuits inside the device. This knowledge helps engineers select the appropriate materials and circuit layout when building the smartphone. Next, consider as GPS system. Physics describes the relationship between the speed of an object, the distance over which it travels, and the time it takes to travel at that distance when you use a GPS device in your vehicle. It utilizes these physics equations to determine the travel time from one location to another. The study of physics is capable of making significant contributions to advances in new technologies that arise from theoretical breakthrough. The Global Positioning System (GPS). GPS calculates the speed of an object, the distance over which it travels, and the the time it takes to travel that distance using equations based on the laws of physics. So, physics has many applications in the biological sciences. On the microscopic level, it helps describe the properties of cell walls and cell membranes. On the macroscopic level, it can explain the heat, work, and power associated with the human body. Physics is involved in medical diagnostics such as X-rays, magnetic resonance imaging (MRI), and ultrasonic blood flow measurements. Medical therapy sometimes directly involves physics. Cancer radiotherapy uses ionizing radiation, for instance. Physics can also explain sensory phenomena such as how musical instruments make sound, how the eye detects color, and how lasers can transmit information. So, the boundary between physics and the other sciences is not always clear. For instance, chemists study atoms and molecules, which are what matter is built from. And there are some scientists who would be equally willing to call themselves physical chemists or chemical physicists. It might seem that the distinction between physics and biology would be clearer, since physics seems to deal with inanimate objects. In fact, almost all physicists would agree that the basic laws of physics can explain two molecules in a test tube work equally well for the combination of molecules that constitutes a bacterium, which differentiates physics from biology. So, the definition of terms like model, theory, and law. In colloquial usage, the terms model, theory, and law are often used interchangeably or have different interpretations than they do, they do in the sciences in relation to the study of physics. However, each term has its own specific meaning. The laws of nature are concise descriptions of the universe and around us. They are not explanations but human statements of the underlying rules that all natural processes follow. They are intrinsic to the universe. Humans did not create them and we cannot change them also. We can only discover the understand them. So the cornerstone of discovering natural laws is observation. Science must describe the universe as it not as we may imagine it to be. Laws can never be known with absolute certainty because it is impossible to perform experiments to establish and confirm a law in every possible scenario without exception. Physics operate under the assumption that all scientific laws and theories are valid until a counter-example is observed. If a good quality, verifiable experiment contradicts a well-established law, then the law must be modified or overthrown completely. So in this slide, we're going to discuss about model. So what is model? Model is a representation of something that is often too difficult to display directly. So you cannot display that directly. So it is an representation. Model is an representation of something that we cannot display that directly. While a model's design is justified using experimental information, it is only accurate under limited situations. An example is the commonly used planetary model of the atom, in which electrons are pictured as orbitary or as orbiting the nucleus, analogous to the way planets orbit their sun. We cannot observe electron orbits directly, but the mental image helps explain the observations we can make, such as the emission of light from hot gases. Physicists use models for a variety of purposes. For example, models can help physicists analyze a scenario and perform a calculation, or they can be used to represent situation in the form of a computer simulation. So this figure is given here. So we have this figure. This is called as planetary model of an atom. So the planetary model of an atom in which electrons are picturized as orbiting the nucleus, analogous to the way planets orbit the sun. Okay, and this is the in this picture. This is the nucleus. Protons, neutrons, and electrons are revolving, means like the planets orbiting around the sun. So these proton, neutron, electron are orbiting around nucleus here. So friends, thank you so much for watching. If you like the video, please share and subscribe to the channel. Thank you so much for watching. Have a nice day.